Water bodies throughout the world continue to be threatened by nutrient runoff. And the visual indicator, algae blooms. The primary sources of this nutrient runoff are aging wastewater treatment infrastructure, ecologically degrading agricultural practices, and stormwater runoff.
It's interesting how we use names and yet we aren't very precise in what their meanings are, and as a result of that imprecision, we lose meaning and lose intention. Many Aboriginal cultures have a word for the wholeness or the oneness of life. Western culture says we are humans or there's nature. There's cultural systems, natural systems, heart, mind, quantity, quality, science, religion, and that dualism that we know from philosophy hurts our perception of life. The minute we say there's nature, we have already separated ourselves. And therefore we objectify it. It becomes a thing rather than processes of life. So the very idea of having a national park system, while I'm glad we have it because we continue to abuse nature, the idea of a national park system is actually absurd. Because what we're saying is, nature, we don't understand how you work. You go over there, we're going to put you in a place and put a fence around you, pat you on the head, say you behave, and we'll go out here and we'll screw it up.
Along with the human settlement in villages and cities came the concept of using water bodies as the depository for waste. Prior to this, human excreta were deposited in nature, and thus the nutrients were maintained in the soil cycle. Water has become the recipient dump. There has been an infusion of macronutrients such as nitrogen and phosphorus, and the environmental effects are profound. In Vermont, like most areas around the world, cities grew up around water bodies for water supply and for waste removal. Waterbury is indicative of the growth of a typical New England town.
The village of Waterbury was incorporated in the late 1800s. It was a place where denser residential development was beginning to occur, and commercial development, of course, was helping to drive that. There were department stores and feed stores and butcher shops and things like that. In order to accommodate that more dense development, the people that lived here, they wanted clean water, so they developed a water system. They bought some land up on the side of Hunger Mountain in Stowe. And it's probably 8 miles up there from here, and by hand they dug those trenches and laid that water line and brought the water down into the village. Getting the clean water to drink was one thing, and you had the Winooski River right next to the village, so it was straight pipe to the river. That's the way that wastewater was handled, not only here in Waterbury, but throughout Vermont, throughout New England, frankly throughout the world.
As time went on, another significant development activity occurred that would impact Vermont's waterways: the expansion of camps and lake cottages throughout the state.
After World War II, people started coming back and coming from southern New England up to northern New England to have small camps and cottages located very close to the water shores of both Lake Champlain and a number of smaller lakes throughout the state.
That's fine when there's not a whole lot of people, or it's one camp that's out in the middle of 100 acres or whatever. I mean, it's really not a particular implication. But I think particularly where you've got camps that are around lakes, and lakes that you want to be pure and pristine lakes, I mean, it's pretty obvious where the sewage is eventually ending up.
That actually triggered the Vermont State Health Department regulations for water and wastewater disposal because of the concern for those small very small postage-sized lots that they would be working on.
It wasn't until 1953 that Burlington had its first wastewater plant, and that wasn't that long ago, really, in the grand scheme of things. When you think about what used to happen is the pipe network went directly to the lake and the river. I think they were thinking about everything from the recreational use to the fact that you were dumping human waste into your receiving water without any treatment, which is where you're taking your drinking water from. So when you think about it, you almost go, why did it take them so long to do something?
As communities realized they needed to protect their water supplies, they started to construct wastewater treatment plants. But it wasn't until the 1970s that real progress began with our wastewater treatment infrastructure.
I think one of the milestones in the water pollution control field was Public Law 92-500, the Federal Water Pollution Control Act. We now call it the Clean Water Act. Passed Congress in October of 1972. A great deal of the wastewater infrastructure in place today was built under that federal program.
It was one of the largest investments of federal dollars in the history of this country that was put into building new sewer systems and better wastewater treatment systems. And as a result, we had a dramatic reduction of the amount of pollution into our rivers and lakes across the nation and here in Vermont.
There's a constant pressure to weaken the Federal Clean Water Act and to deprive our agencies of the resources they need to enforce the laws in the name of progress, in the name of economic development. And I think that that is a broken way to pursue continued viability for our communities.
A most recent threat to the Clean Water Act is Federal Bill 2018, which passed the House of Representatives in July of 2011. This bill aims to strip EPA's authority over states' water quality and would turn the clock back 40 years on clean water protection.
We need to end this debate over weakening our laws and lowering the barriers for development.
Look at the record of what states have done over the course of the last 100 years dealing with water quality. And it isn't that the federal government overreached and the states had done too much. We have the Clean Water Act because the states consistently failed to meet their obligations.
When Congress wrote the Clean Water Act, they envisioned it as the mechanism that would kick in when you have a situation like you have with Lake Champlain, where there are multiple pollution sources and every single one of them is dumping more pollution into the lake than the lake can safely handle.
In the 80s and 90s, we began to realize that phosphorus was one of the additional problems associated with the effluent, the discharge from these sewage treatment plants, that as they were run, they didn't always remove enough of that. And so there was a dramatic effort that went into investing in upgrading those plants to remove phosphorus.
In January of 2011, the United States Environmental Protection Agency disapproved Vermont's TMDL. The total maximum daily load is the pollution budget for an impaired water body, and it identifies allowable pollution loads from various sources throughout the lake. The EPA is now taking the lead on determining the limits and quantities as they reestablish Vermont's TMDL. Many of Vermont's wastewater treatment plants were upgraded to operational levels that allow for 0.8 milligrams per liter of phosphorus to be discharged. The current debate is whether this number is sufficient to restore water quality.
The mechanism by which the nature and extent of the problem are defined is the TMDL process, total maximum daily loads. So the science says that a certain number of pounds of phosphorus needs to be removed from, say, Lake Champlain to achieve water quality. That then, in my business, defines the nature and extent of the problem that we then need to solve.
Waterbury's treatment plant It's an aerated lagoon system that was built here in the early 80s. If we had been told to design a treatment plant and were told that we had to treat for phosphorus, this type of plant never would have been built. In 2005, we were told that we needed to begin to treat for phosphorus and get to 0.8 milligrams per liter. But because the TMDL's been invalidated, the state hasn't told us yet whether 0.8 is going to be good enough, and we're in limbo now.
Waterbury is one of the last wastewater treatment plants in Vermont to upgrade for the treatment of phosphorus. As the TMDL is being reconsidered, the EPA and the state are evaluating all wastewater treatment plants throughout the basin to determine if the 0.8 milligram per liter phosphorus discharge level is sufficient.
The setting of the limitation needs to match the environmental setting. If a very pristine pond can assimilate only a very, very small amount of phosphorus, then a very tight phosphorus standard would be appropriate, maybe 0.1 milligrams per liter. But there are circumstances where the sensitivity is less and perhaps 0.5 or 1 milligram per liter would be sufficient. So I would argue that you need to start with a resource you're trying to protect, establish a standard, and implement it.
Most of our plants are down around the 0.8 mark. Getting down to 0.8 to 0.2 can sometimes be quite expensive. It might double or at least increase by 50% the price of otherwise building a plant. We're talking millions of dollars, and so there become some trade-offs as we're talking to communities about doing a whole host of other kinds of work that will address water quality. We want to work with them to make sure we're making balanced decisions and spending the money where it's most effective.
The technology does exist. However, it's just an expensive way to go to remove phosphorus, and you have to determine whether it's truly a benefit to Lake Champlain.
What scares people about the cost numbers is that the way the opponents of change, the folks that are defending the status quo of this horribly over-polluted lake, what they try to do is scare you with the big number. So it's going to cost $60 million to fix all the sewage treatment plants in the Lake Champlain Basin. What they're not telling you is that that cost is spread over time and over households and over businesses. I think it's all about perspective. If you said, would each household be willing to pay $1, $1.50 more, $2, even $5 more a month on their water and sewage bill over the course of a year to have a lake that's clean and rivers and streams that are clean?
Only in times when we have catastrophe do people understand how valuable. And Katrina hit, and what was the first thing they were trying to get back online was the water treatment plants. You can't live more than a few days without clean water, and people gripe to spend another $25 for their water and sewer a month, and they'll just pay the cable bill.
The infrastructure in the United States is failing right below our feet. In addition to our central plants, there is a vast transport network that needs to be maintained.
Some of that infrastructure is really old, like over 100 years old. And over a 4-year period, there's been more than 150 instances where somewhere along the collection and pumping infrastructure where we're getting the wastewater from our homes and businesses and to the treatment plant have failed and have resulted in discharges of untreated sewage going into our waterways. This infrastructure failure, the discharges that result from that, are not accounted for. Never mind the bacteria that comes along with that raw sewage, but how much phosphorus are we putting in as a result of our failing and outdated infrastructure?
How to pay for the pipes themselves is huge. And then at the treatment plant level, there's all the biosolids. It used to be land applied, then we went to composting in Canada. Canada didn't want us anymore for composting.
Right now, this area is landfilling, and putting it into a landfill, which is too bad because the the state of Vermont and the city of Burlington believes in the beneficial reuse of biosolids.
The reutilization of human waste for valuable soil product is a key component of ecological design. However, this process relies on our ability to ensure that biosolids are free of toxins.
Just about anything that can go down the sewer goes. You get everything from the toilets, from the storm drains, from industry. Industry uses the sewer as a dump, both legally and illegally.
The EPA regulates 9 or 7 substances out of all of the things that could go into the sewer. And all is thousands, and they go.
For a long time, I saw the number of 20,000 substances used in our manufacturing processes. That is, to make all the stuff we see around us, our stuff that's in our cell phones, our clothing, our everything. 20,000 substances. I thought that was a pretty good number. I recently seen 100,000 substances. And not just by industry, but by us as homeowners with all this stuff we got under the kitchen sink that we use for cleaning and all the pharmaceuticals and so forth. All that stuff winds up in the sludge.
They're not obliged to manage or to remove or to eliminate these toxic substances. So we put them on our cropland. It's some kind of science fiction.
Under the Clean Water Act, the EPA is obliged to do something called a sludge inventory. And they go around the country collecting samples of sludge to see what's in it. One of the things that's in every sample is flame retardants. And they are what's called a hormone disruptor. And they throw our reproductive systems off. That's in every sample of sludge. And there are plenty of other substances. They can't test for 100,000, 20,000, 10,000. The aim of the sewer is to give industry a free ride. They're not having to pay for the pollution. We pay. We eat it.
What this is really about is the interaction between food cycles and industrial cycles. These are cycles that need to be separated.
When we are able to ensure that industrial toxins are separate from the human nutrient cycle, the stage is set to redefine waste disposal as nutrient recycling.
From a long-term point of view, the way we treat sewage today is wrong, even though it works. They're expensive to build. They use a lot of chemicals, which the price of these is increasing every year, and they use a boatload of energy.
John Todd and I started a business 20 years ago called Living Technologies, which asked the question, can we do wastewater treatment the way nature does wastewater treatment, which essentially is in a complex wetland. So what we did is we built these greenhouses that housed constructed ecosystems that were designed to take the waste flow out of sewage pipes and process it into healthy plant roots and snails and bacteria and leaves.
Eco-machines, as they're now called, were comprised of thousands of species of life forms. When they were brought together in the presence of the waste, they created whole new ecologies which had really never been seen before. And that made me realize that if we could unlock the instructions of nature and design systems to solve human problems using the intelligence of an ecosystem, we could change the world.
Eco-machines have been built around the world with tremendous success. One was built in Berlin, Maryland. that treated 1.5 million gallons of high-strength wastewater from a Tyson slaughterhouse that processed 1 million chickens a week. An eco-machine in Fuzhou, China, treats 750,000 gallons a day of raw sewage in a 600-meter canal. The technology reduces the negative impact of the pollutants in the canal while meeting several secondary effluent standards, and remarkably, the canal has been established as a habitat for 3 species of edible fish.
The Interstate 89, the Sharon Rest Stop, that's a system that produces flowers as a byproduct. Not commercially, but it does produce flowers as a byproduct. It's a design issue to create something that will actually earn money. For example, when we operated for a number of years a EPA demonstration facility here in Vermont, the way we dealt with sludge at the end of the process was to grow large numbers of fish. We bought them at 99 cents and sold them into the water garden industry 9 months later at $10 a piece. And there were 10,000 in that tank. That's $100,000 we're looking at. Now, mind you, that's an exceptional case, but you get the idea? Because there's a culture, an established culture around water and waste treatment, we've had very little luck working with towns and cities. We've got to stop thinking of it as an isolated discipline in civil engineering and thinking about it as part of the new great agriculture, which, if it's developing anywhere, is developing in Vermont.
We are still in the outmoded mindset of the one big plant. You know, let's build the big sewage treatment plant and collect wastewater from far-flung regions of our communities, instead of looking at what they do in a lot of other states, which is decentralizing wastewater.
Sometimes it can be more effective and efficient to use on-site wastewater treatment systems, smaller systems that serve, say, 10 houses.
Those lower lake elevation areas, that would be a perfect place to put a cluster system and put individual septic tank pumps to each one of those camps and then pump it up to one treatment and disposal field that is away from the lake.
Significant solutions can be made by individuals with design techniques in the home. Rainwater can be captured and used in biological systems, or purified for domestic use. Separation of gray water from septic or black water makes a profound impact on municipal wastewater systems. Gray water can be treated on site and sent to biological systems and rain gardens, and with sufficient purification can be recycled for continued domestic use. The final step is the compost toilet, where nutrients can be reused on the land around the house.
Homeowners do have a say in this, and they should have a say, and they may need to go for more education, because it's not just about septic and it's not just about disposal anymore. You're really looking at how do we treat this wastewater coming out of our houses so that it won't be impacting our groundwater or our water bodies.
If you look at the Federal Clean Water Act, one of its goals, which was supposed to be accomplished by 1985, was that we would eliminate water pollution altogether. And I think it bespeaks an optimism that once existed in Congress, wouldn't it be nice if we had that back, about what America was capable of.
Really, there's a common set of values around the importance of maintaining and protecting the environment in this state. There's a sense that protecting the environment is part of our shared prosperity. So if we can't get there, it's not because we disagree, it's because we're not communicating effectively.
The more and more that we grow in relationship, the more and more life will actually recover. This is a personal re-engagement with the workings and purpose of life. We need to live fully with the land. We need to understand our purpose to add value in this ecosystem. And we need to live so that we are developing ourselves and developing new potential. That's what evolution is. It's a process of becoming one with life again.